This is a lecture over complex numbers for Math 107. Complex numbers are numbers that include both what's called a real part and an imaginary part. And sometimes the word imaginary part sounds like some strange thing that you have to imagine. So to explain where the wording imaginary part comes from, I'm going to go through a little bit of the number system, the different hierarchy of numbers that we use. We start off, I'll start at the bottom here, we'll start with what are called natural numbers. If my pen would write, that would be a very good thing. Okay. So these are natural numbers. Writing well. Okay, that's okay. And they're what you would say are the counting numbers. 1, 2, 3, 4, etc. Keep going. Supposedly those were the first numbers that people started to use. After that, the 0 is added. So we're going to add in a 0, and when we add in the 0, we get what are called the whole numbers. So they include the natural numbers, which is why I'm writing them a little bit above them. And they start with 0. Now there's a lot of stories about where 0 came into our what's called Western number system. Where the 0 came from is the Arabs had conquered a lot of like Spain up into what's called former Yugoslavia, and then all the way to the east as well, India, and parts of India. And there in India, they met a mathematician. Well, they met several mathematicians. One in particular was named Brahmagupta. And in the olden days, India and China were very closely related countries, and their mathematics was also shared. And through this Brahmagupta, they were introduced to the use of 0. 0 had not been used before from the Greeks, Babylonians on into the West, because it was the conceptual idea of what is 0. There can be nothing. How can nothing be? And so they didn't use 0, although in calculations, people would go and use 0 quietly off by themselves in the corner, so to speak, and then return for their calculations to show the effect of it. They had many calculations to do, of course, because there was a lot of shipping, trade, all kind of things to keep track of. Well, when they learned of this 0, and it was called call, and it was written with basically nothing, just like a blank. Right. The Arabs brought it back to their libraries. They gave it the symbol 0 that we use today. And different peoples, different mathematicians came to the libraries and studied and learned about 0. And that's how 0 got into the coordinate system, or to the number system. So let me erase that a little bit here. Give us some room. The next numbers that got added were the negative numbers, and when we add them, we call them integers. That whole system. So we start with, say, -3, -2, -1, the 0, 1, 2, 3, and you see it encompasses the ones before it, the whole numbers, and the natural numbers. Well, they're all get encompassed and wrapped up into the integers. Integers also were in use in China and India way before they were used in Western Europe. And there was a lot of controversy to introducing them. And now we're quite familiar with them in terms of negative temperatures, negative, debt, that sort of thing. Okay, now the next level that we're going to add are fractions. And we call those rational numbers. And rational numbers can be written as a ratio. Remember, this is the word ratio. It doesn't mean rational as in terms of thinking process. It's a ratio. And it's going to include now all the ratios of integers. Of course, all these integers themselves are, for example, 2 is a fraction. It's 2 over 1. This includes 3 over 2. Any ratio, all ratios of these integers, -2 over 6, etc. Now there's still a group of numbers that are left out, and those are the numbers that cannot be written as ratios. The fact of the existence of these numbers, which are called, for contrast, they're called irrational numbers. And not that they have a problem thinking, it's more that that's a contrast to the word ratio. Numbers that cannot be written as a ratio. And there's many stories concerning the introduction of those and problems that they had, especially in the time of Pythagoras with the Greeks, of admitting the existence of these numbers. So it's quite a history here. But you're familiar with pi, of course. Pi is an irrational number. It cannot be written as a ratio of two integers. Another that you might have seen before is E, Euler's number. Square root of 2, square root of 3. These are irrational numbers. Now, the irrational numbers don't include the rational numbers. Instead, as a group, they make up the real numbers. And that's your real number system. Now, there's several things you can't do in real numbers. One is take the square root of a negative number, and the other is to divide by 0. We can't do anything about dividing by 0. However, we can introduce the square root of negative numbers, and that turns out to be extremely handy in math and in physics. But what are you going to call them? Well, recall here that we had ratio and then irratio, or rational and irrational. Now we're working with real numbers, and to get a number system or a group of numbers that contrast with the word real, you could use the word unreal, but instead the word imaginary is used. And those are all the square roots of negative numbers. Negative 2, square root of negative 25, on and on. Okay. The imaginary numbers don't include the real numbers. However, as before, we combine these two and we call them complex numbers. So hopefully that dispels a little bit of why we use the word imaginary for certain numbers. It's customary to write an imaginary number, I'll call it Z. It has two parts. Remember, those two were combined. One part is real. I'm going to call that, I'll use an X for that. And then there's an imaginary part. And I think you may or may not have seen this before. So a complex number contains a real part, often just RE for short, and it contains an imaginary part. And those two parts make up a complex number. The I here signals that this is the imaginary part of the number. There's no I associated with the X. That's the real part. For example, Z equals 3 plus 7I. This is the real part. Here is the imaginary part, and we have to keep them separate. Now the question is, what is I? We'll look first. Whoops, let me get a pen here. Let's just look at one imaginary number. We'll call it the square root of, let's say, minus 5. Well, I can write this as minus 1 times 5, correct? Now, because minus 1 and 5 are factors, we can take the square root of each separately. So I can write this as the square root of negative 1 times the square root of 5. Remember, if it looked like this, 3 plus 4, that is not equal to the square root of 3 plus the square root of 4. But if you have 3 times 4, that is equal to square root of 3 times the square root of 4. So let's return now to what I wrote at the first place. The square root of negative 5 can be written as the square root of negative 1 times the square root of 5. I'm going to define a letter, the letter I. In electrical engineering, you'll use a J if anyone goes into electrical engineering. And that I is going to mean the square root of negative 1. And that will hold for all negative numbers. Minus the square root of 100, the square root of negative 100, that's I times the square root of 100. You can go ahead and work out the math here, and that becomes I times the square root of 10. You never leave a number in this form with that negative sign inside of there. So that's I times the square root of 100, well, it's not the square root of 10, just plain old I times 10. Alright? So we have I is defined to be the square root of negative 1. Now we can do some math with complex numbers. Oh, sorry, I didn't get a pen. Here we go. Let's say the first complex number, z1, is 3 plus 4i. It doesn't matter what order you write it in. You can write i4 or 4i. It doesn't matter. And let's say z2 is 6 minus 12i. Now if you want to add these numbers together, you add the real parts and you get a 9. Then you add the imaginary parts and get a negative 8i. You add the reals separately. You add the imaginary separately as though they're both in different buckets, and you don't mix up the buckets. The real numbers you add together, the imaginary numbers you add together, and that's your answer. Sometimes a complex number will be what's called purely real. For example, it could be 12. That is still a complex number. It's called purely real because the imaginary part is 0. This is equivalent to 12 plus 0i. You could also have a complex number that's purely imaginary. Say 6i. This is purely imaginary, but you treat them just the same as you do otherwise. So this is a 0 real part plus 6i. So when you go to add numbers like that, you remember that either the real or the imaginary is 0. So say z1 is 16 and z2 is 4 plus 7i. If I add those or subtract them, then I add the real parts together, which gives me a 20. Now there's nothing here. There's a it's really 0i. So the answer for the imaginary part of that sum is 7i. This goes for addition or subtraction. Multiplication is a little bit different because you have to resolve one of the powers of I. So now I'm going to try to multiply two complex numbers together. Let's say 2 plus 7i times 3 plus 4i. Now you would know how to do it if it was 2 plus, say, 7x times 3 plus 4x. You would FOIL, right? First term would be 6, the next term would be 8x, next one would be 21x, and the last term would be 28x squared. You do the same thing up here. The I operates, or you could treat it as though it were an x. So I multiply this out, I get 6. Then I would have 8i, I would have 21i, and the last term would be 28i squared. Now with the x's, that's as far as you go, although you can combine these cross terms. We can do that right here. 6 plus 29i plus 28i squared. So I could write that here with the x's, 6 plus 29x plus 28x squared, and then, in this case, this is done. But in the case of imaginary numbers, you are not done. And I'll show you what to do next. First, to get some room. Okay. If I is equal to the square root of negative 1, what is I squared? I squared is equal to negative 1. This information has to be used. So this I squared gets replaced by a negative 1. 6 plus 28i plus 28 times minus 1. That's the same as 6 plus 28i minus 28. So you multiply this term by a negative 1, just essentially changes that sign. All right, notice what is real. This is a real number. This is a real number. This is an imaginary number. Now I can combine real numbers. So these two real numbers are going to be minus 22, and then the imaginary number stays by itself. This is essential. When you FOIL these numbers, you must resolve the I squared term as negative 1. This is real. In fact, it was real before, but this is real and can be combined with the other real number in this list.